name is MJ O'Neill, and this is an instructional video on how you can better assess the viability of a microhydro turbine unit for your river, creek, or stream. With this video, I'll show you how easy it is to get out there, out of the classroom, and into the field, into the creek, and just show you how easy it is to conduct head and flow assessment to better assess the viability of a microhydro turbine unit for your river, creek, or stream. A couple of areas here in the Boone, North Carolina region where I'll be showing you how head and flow assessments are done are going to be in Winkler's Creek here in the outskirts of Boone, also in the New River right by State Farm fields and parking lot, and also I'll be showing you an actual microhydro power turbine unit over in Todd, North Carolina at Molly's Branch Farm. In this demonstration, I'll be showing you how to calculate the elevation drop, or in other words, head, taken from the top of where your proposed siting for the intake is, down to the bottom where your powerhouse or turbine is located. We'll be doing this by using a site level. The two most accurate methods of finding the elevation drop are direct height measurement and by measuring water pressure. The method that I'm demonstrating here is the direct height method by working uphill from where the turbine will be up to the intake. Normally, you would want an assistant up the hill from you in order for their feet to act as a marker for the spot where the site level is actually level, but as you can see, I didn't have one at the time, so I picked a specific piece of dirt or rock to mark the spot instead. This diagram is a more accurate representation of how to go about this method. As you can see, the man in red's feet are perfectly in line with the site level that the man in green is holding. If the man in green were to measure the distance between the site level and the ground he is standing on, he is therefore measuring the head, or the elevation drop, for that leg. By the man in green standing where the man in red once was, and making that same measurement again all the way up to where the proposed siting for the intake will be, they are measuring the elevation drop, or head, of that particular site. In this demonstration, here in Boone, North Carolina, on the New River right by State Farm parking lot, I will be showing you how to calculate the amount of flow of your river, creek, or stream to better assess whether or not your resource is a viable one for a microhydro power unit. There are three main methods of going about this. They are the Weir method, the 5-gallon bucket method, and the float method, which I will be demonstrating now. In order to carry out the float method, you must first measure off an upper and a lower part of the stream to run your float method on. This can be done with your average everyday tape measure or any measuring device such as this one shown here. We will also be using a stopwatch, which I'll show a little later. And to act as a float, we will be using an orange. Why an orange, you ask? Oranges neither float nor sink, making them an excellent flotation device for our purposes. In order to calculate this distance taken from the upper portion where you're measuring to the bottom portion, it helps to have a friend, but in this case it's innovation at its best. Be sure to pull the measuring tape nice and tight to have the most accurate measurements. Here you have it, folks. 27 feet. Now, using our orange that I talked about a little bit earlier, and a stopwatch that hopefully works, we can go ahead and conduct our float method. It always helps to have a friend upstream to drop the orange into the water at the start, but if you don't have any friends, go ahead and chuck it on up there. Start your time when it hits the top part of the stream. And stop it when it hits the bottom part of the stream. Be sure to record all your times and data during this whole process. 11.60.
And then repeat the process over and over again to get the most accurate results.
Start. Stop. 12 seconds. Start. Stop. 13 seconds. Start. Stop. 18 seconds. Start. Stop. 14 seconds.
Now we're going to use our measurement tape again to measure the average depth, which we will use in the calculation later on to find the flow.
6 inches. 6 inches. 7.5 inches. 1 foot. 11 inches. 8.5 inches. 8 inches. 6 inches. 4 inches. 4 inches. 5 inches. 5.5 inches. 5 inches. 4.5 inches. 4 inches. And 2 inches.
The only other factor that we'll have to take into consideration for the calculation that we'll do later on is the bottom of the stream. And in the hydro industry, the commonly used factor for that is 0.83 to correct for friction. Using our depth measurements that I took earlier, we will then have to convert those to feet and add them up. Depending on how many data points you did, you will then have to divide that by however many data points that you took, which gave me an average depth of 0.49 feet. I wasn't able to do it that day, but the width of the stream when I went back and measured it was 40 feet. And as I just explained, the surface roughness is to be considered 0.83. Then all we had to do is 0.49 feet, which was our average depth, times our width of the stream, 40 feet, which gave me 19.6 feet for the cross-sectional area. After that, since 1 foot per second equals 60 feet per minute, we will then have to do 19.6 feet times 60 feet per minute, which gave me 1,176 cubic feet per minute. All we have to do then is take that and multiply it by the surface roughness, which is 0.83, which gave me a grand total of 976.08 gallons per minute.
In this demonstration on Winkless Creek here in Boone, North Carolina, I'll be showing you another method on how to conduct a flow assessment. I will be doing this by using the 5-gallon bucket method, using a 5-gallon bucket, of course, and also a stopwatch. Concept's pretty easy. Fill up the 5-gallon bucket, start the clock at the beginning, stop the clock when it ends. All you need to do afterwards is a simple calculation, and you can see what the flow of your stream is using that. So let's do it. Start it up.
The 5-gallon bucket method is one of the most popular ways to measure flow, but the only problem with it is that you have to find a point in the creek where all of the water from upstream is siphoning into one part of the stream down below where you fill the bucket. Not only did I almost fall into the creek many times, I also wasn't able to capture all of the water cascading off the falls. So here is a hypothetical site where you could catch all of the water. If you filled a 5-gallon bucket in 2.5 seconds, then this stream would warrant a 300-gallon per minute flow. Now we're going to be visiting Molly's Branch Farm out in Todd, North Carolina, that has a complete microhydro turbine unit complete with a diversion site, an intake, and all of the balance of system components required, along with a Harris Hydro microhydro turbine. Some of the specifications behind the Molly's Branch microhydro system are that it has an 85 gallon per minute flow entering into the turbine with a 300 gallon per minute stream flow, so only about 1/3 of the stream is being taken out in order to avoid any ecological effects. There is a 4-inch high-density polyethylene penstock that runs all the way down into the turbine from the intake. At the intake site itself, there is a double silt trap. There is a 4-inch overflow pipe and also a 6-inch diversion pipe that can hold 100 gallons per minute. Molly's Branch hydro system also is able to provide power and heating to the barn so that all the animals that come in there during the winter can stay nice and warm. And also, if the grid goes down, the hydro system kicks on and vice versa. Molly's Branch microhydro turbine unit was complete with a powerhouse, a diversion site, and an intake. Here's the intake here. As you can see, the water comes in through the diversion site up above where I showed you. Comes in here, fills up. Then is run through a screen. From there, another screen below, where it is then put through a penstock, which leads to the turbine down below. The double silt filtration system at Molly's Branch Farm on the intake component is a fairly easy system to clean off, as you can see here with just a quick swipe of the hand. This component of the balance of system is essential towards the life of the turbine and also the penstock, because if any contamination buildup gets in the turbine or the penstock itself, it can damage it. From the intake site, the water is then run through a penstock, over some creeks using some structural systems, and then leads all the way to the powerhouse where the turbine is housed. When water reaches the end of the penstock, it then flows through this pipe that I show here, then down through this tube, and then is distributed throughout 4 nozzles in the Harris hydro system. Water then goes through the bottom of the turbine, then flows out through the tail race. And as you can see, since all the water is redistributed back into the stream, there is no ecological impact. Thank you for watching my video on how to assess the viability of a microhydro turbine unit for your site. Hope you've learned something today about head and flow assessments. It goes without saying that the more head and flow that you have for your river, creek, or stream, the more power output that you'll produce.
for either transferring onto the grid or producing electricity for your home. Another major component to keep in mind is that not everyone has been able to hit the energy lottery and has a reliable water resource by their house that is appropriate for a microhydro turbine unit. You might conduct these head and flow assessments and find that your site is not an appropriate one for a microhydro turbine unit, but we are lucky enough to live in a day and age that there are other renewable energy resources out there available to us, and you can implement any one of these alternative energies to fuel your energy needs and electricity needs for your home, and you can even attain money by transferring this electricity and power onto the grid even, and you're doing a favor for the planet and you're doing a favor for future generations that are to come. Thanks again for watching my video on how to assess the viability of a microhydro turbine unit for your river, creek, or stream. Here's a quick blooper reel to leave you out on a comical note. Ah!